All right, today let's talk about the internet's invisible delivery service. You know, the basic rules that make everything you do online actually, well, work. But before we really get into it, did you know that every single time you connect to something, a huge choice is being made behind the scenes? Yep, that's right. Every time you load a website or jump on a video call or download a file, a decision is made for you in the background. Do we need this data to be absolutely perfect down to the last bit? Or do we just need it to get there as fast as humanly possible? That choice, right there, is at the heart of everything we're going to talk about. Because you see, without some kind of system, sending information across the world would be a total disaster. The data that makes up a simple web page could arrive all jumbled, completely out of order, and just useless. To really get the solution, you have to appreciate the problem first. So, to really understand why we need these rules, just imagine for a second what the internet would be like without them. It would be a world of pure digital chaos. Think about it. You're trying to load a website, but big chunks of it, like the images, are just gone. Or maybe the text shows up, but it's totally backwards and unreadable. You try to download an important file, but you only get half of it, which means the whole thing is corrupt and useless. This is exactly the kind of mess that needed a solution. And that solution, the hero that brings order to all this chaos, is a protocol called TCP. You can think of it as the internet's most reliable, super careful postal worker. So TCP stands for Transmission Control Protocol, and its entire job, its whole reason for being, is to make one simple promise. Every single piece of your data is going to get to its destination, and it's all going to be put back together in the exact right order. No ifs, ands, or buts. So how does it pull off this perfect delivery? Well, it uses something called connection-oriented communication. Before a single bit of data is sent, the two computers have to formally set up a connection, kind of like two people shaking hands and agreeing to have a conversation before they actually start talking. This little agreement is called the three-way handshake, and it's actually pretty simple. First, your computer sends out a message called a SYN, which is basically it asking, "Hey, you there? You ready to talk?" The server on the other end then replies with what's called a SYN/ACK, saying, "Yep, I'm here and I'm ready." Finally, your computer sends one last ACK, which just means acknowledgement, to say, "Awesome, here comes the data." Only after all that happens does the transfer actually begin. So the main thing to remember is that TCP is built from the ground up for reliability. It guarantees delivery, so if a piece of data gets lost along the way, TCP makes sure it's sent again. It ensures everything arrives in order. This super careful nature makes it absolutely perfect for things where every single bit matters, like loading websites correctly, downloading files completely, and, being able to actually read your emails. But all of that checking and confirming and handshaking takes time. It adds overhead. And sometimes you just don't have that time. What if you need speed way more than you need perfection? Well, that brings us to our second protocol, UDP, the Speedy Messenger. UDP has this fantastic nickname. People call it the Fire and Forget Protocol, and honestly, that name tells you almost everything you need to know about it. It is the polar opposite of the careful, cautious TCP. UDP, or User Datagram Protocol, works by, well, just sending data. It doesn't set up a connection, it doesn't wait for any thank yous, and it definitely doesn't guarantee that the data will even get there. It just throws it out into the world and hopes for the best. And this right here really highlights the fundamental difference between the two. While TCP is connection-oriented, it has to do that whole formal handshake thing, UDP is completely connection-less. It doesn't bother with a session, it just fires away. So why on earth would anyone use a protocol that sounds so reckless? Well, it comes down to one word: speed. By skipping all the handshakes and all the acknowledgements and all the error checking that TCP obsesses over, UDP has way less overhead. It's lean, it's efficient, and it is incredibly fast. So this brings us to the final showdown. But it's not really about which protocol is better, because that's the wrong way to think about it. It's about which one is right for the job. It's the ultimate trade-off between getting it right and getting it fast. Okay, let's just lay them out side by side. You've got TCP, connection-oriented, super reliable, but slower because of all its extra work. It's your go-to when you need perfect data. Then you've got UDP, connection-less, not so reliable, but way faster. It's the undisputed champion for situations where speed is everything, like live video streaming or online gaming, where a single dropped pixel is much better than a long stuttering freeze. So here's the key takeaway, the main thing to remember. These two aren't competitors. They're just two different tools for two very different jobs. You use TCP, the reliable one, when every single bit is critical, like a file download, where one wrong byte could corrupt the whole thing. And you choose UDP, the speedy one, when getting the data there right now is more important than it being perfect, like in a live conversation where a tiny audio glitch is way better than a long, awkward pause. And that kind of leaves us with a final thought. The next time you're on a video call and it gets just a little choppy for a second, but the call doesn't drop completely, you'll know exactly what's happening. You're actually watching UDP in action, making the smart sacrifice of a few pixels for the sake of real-time speed. It's the internet's invisible delivery service, always making the right choice in the background to make your digital world run as smoothly as possible.
If this helped, consider subscribing to BitScoop for more simple tech explainers.